All right, so previously we learned some colligative property equations that explain the properties of solutions depending on how much dissolved stuff you have. And then we learned with the Van Hoff factor that the amount of stuff you have dissolved isn't always exactly the same as the amount of stuff we put in. And so we have to be careful with this. So we can insert the Van Hoff factor I into all of these previous colligative property equations. So for example, we had delta T boiling slash freezing is equal to malal K B slash KF, whichever one you're looking at. Now we can insert an I into this equation because maybe our solute is acting like more than one solute particle, right? If this was sodium chloride, it'd be closer to 2. Same thing with the osmotic pressure, right? We said osmotic pressure is equal to MRT. Now we can insert an I there as well. And so you just got to kind of be careful with this stuff. So let's go ahead and take a look at an example really quick. And so we'll say 4.2 grams of sodium chloride in 125 grams of water. Well, I'll tell you the freezing point is negative 2.1 degrees Celsius. And I want to know, what is I? What is the Van Hoff factor of sodium chloride in this situation? So the first thing we have to recognize is that the normal freezing point of water is 0 degrees Celsius. And then in some kind of table or something, we got to look up KF, right? This constant. It's 1.86 degrees Celsius per molal. So now would be a good time to pause the video and work through this problem and try to solve for I. So let's go ahead and try to figure this out. So delta TF is going to be equal to I times molal KF, right? We can take this KF, we can plug it right into here. And then we have to figure out our other components, right? Delta TF is going to be the difference between 2.1 and 0 degrees Celsius, right? So this is a pretty simple problem. It's just going to be negative 2.1 degrees Celsius or positive 2.1 degrees Celsius. You got to be careful with the sign. It depends on what value this KF is. Sometimes they'll give it as a positive value, sometimes a negative value. You just kind of got to make sure it makes sense. Next up, we have to solve for the molal of this solution. So we know molality is equal to moles solute over kilograms of solvent. And so I think I give you that. No, I don't. Okay, so you have to convert 4.2 grams sodium chloride into moles of sodium chloride. I'm not going to show you how to do that. I'm going to assume you can figure out how to do that. If you have questions, let me know. You should get 0.719 moles of sodium chloride over the kilograms of solvent. We just take this 125 and convert it to kilograms. So you should be able to do that pretty easily as well. You'll get 0.125 kilograms. Again, if you have questions, feel free to let me know. And then you get a final answer of 0.5752 molal, right? And so then we just take this equation, reorganize it such that we want I by itself. So we'll put I by itself. So it'll be delta TF times molal over KF. Plug all those numbers in, the units will work out. And then you get a final value of 1.96. So just be careful when you're doing these colligative property questions if you're dealing with electrolytes, right? Because the Van Hoff factor can show up in any of these.